Hello, class. So today we are going to go over 4.2, the natural exponential function. Okay, so 4.2. The natural exponential function. So in 4.1, we covered exponential functions. So this is also an exponential function. It's a very special one where the base is the number e, Euler's number. Okay, so we'll talk about that. And then we'll take a look at how to evaluate these and how to graph them and how to use them in compound interest problems. Okay, so the number e is equal to 1 plus 1 over n raised to the n power as n gets very, very large. So there's usually a limit involved with this. So as n gets very, very large, then the answer just sort of tapers off and is basically 2.718. It goes on forever, just like pi. 2.71828. If you punch this into your calculator, 18284590452, and it just keeps on going, like I said, just like pi. Okay, so it is an irrational number. Okay, like pi. Okay, and you should check on your calculator to make sure you have and can locate your E button. Okay, and so the natural exponential function would be this exponential function where E is the base. Okay, so very similar to just exponential functions in general. Okay, so oftentimes we call this one the exponential function, even though the other ones are as well. Okay, so let's take a look at evaluating them. Again, you definitely want to check to see that you can punch these into your calculator correctly. Some calculators require that you enter the exponent first and then e. So now is a good time to figure out what your calculator prefers. Okay, so I'm going to give you 4 problems to try. Okay, so these are the 4, e to the 3rd power, 2 times e to the negative 0.53, e to the 4.8, and e to the 1.3 times 0.07. Okay, so go ahead and hit the pause button and get your calculator. You can use the one on your phone. Again, make sure that you turn it sideways so you get the scientific calculator. Hit the pause button and go ahead and try that first one. And then when you're ready to check your answer, go ahead and come back. Okay, so for letter A, you should have gotten 20.08554. Okay. And go ahead and hit the pause button and check letter B. For letter B, you should have gotten 1.17721. Okay. Go ahead and hit the pause button and try letter C. And then letter C, you should have gotten 121.51042. And go ahead and hit the pause button and try letter D. For letter D, you should get 1.095269. Okay, so if you did not get that, check to make sure that when you use your parentheses, when you do this problem over here, maybe you have this button. So maybe you have this button for your exponent. Okay, and then go ahead and use your parentheses and type in all of this here. 1.3 times 0.07, and then close your parentheses. Okay. Okay, so graphing, very similar to 4.1. Okay, so for example, if we are going to graph f of x equals e to the x, okay, if you want to make a table, you can. These are all good numbers to try. E to the 0 is 1, e to the first is e, which is roughly 2.7, and negative 1 is going to give us 1 over e, or 1 over 2.7. Okay. So when we graph this, again, we do have a horizontal asymptote at 0. Okay. So right here. And then our points, we have one at 0, 1, 1 e, and e is about 2.7. I promise I won't break out my tape measure. And then negative 1 and 1 over 2.7. Okay, so very similar to 4.1, and then so are the transformations. So if you have e to the x plus 5, then you shift it up 5. If you have e to the x minus 5, then you shift it down 5. Okay, so let's have a look at compound interest problems using this one. Okay, so in the last section when we talked about compounded interest problems, we said that it was compounded monthly or compounded weekly or compounded daily or compounded quarterly. Okay, so when we had those types of compound interest problems, we used a very specific number for n. Okay, so here what's going to happen is it's not going to be compounded a certain number of times a year. Your interest is just going to be compounded continuously. Okay, so continuously. So there's no particular n value. So continuously compound Compounded interest. And that's going to be the key word to help you distinguish what kind of compound interest problem it is. Is it the compounded n times or compounded continuously? Okay. The compounded n times uses that other formula, a equals p parentheses 1 plus r over n to the nt. Okay. This one, when it's compounded continuously, there is no n. There's your principal amount. And what happens is we're going to be using this, E, Euler's number, and your exponent is going to be R times T. Okay, so there is no n because it's not being compounded like 4 times a year or anything like that. It's compounded continuously, so we don't need an n value. Okay, so all of these, all of the variables here, a, p, r, and t, still represent the same things. Okay, so where a is the final amount, p is your initial amount, okay, r is your interest rate, and make sure that it's in decimals, and t is your time in years. Okay. So E here is not a variable. E is a number. Okay, so let's put a little note there. So sometimes students forget. Okay, E is not a variable. Okay, E is 2.71828. Okay. All right, so let's take a look. So suppose that Ms. Cortez invests $6,500 into an account that pays 4.2% interest compounded continuously. Okay, I'm going to write that word in a different color. This is your key word, compounded continuously. Okay, so that's the key word, continuously, that will be your cue to use this formula up here, P-E-R-T. Okay, how much will she have in the account after 25 years? Okay, so let's take a look at our variables here. So Ms. Cortez invests $6,500. So this here, I'm going to go ahead and use blue. Okay, so 6,500, that's our P value, into an account that pays 4.2%. That's our R value, but we want to use the decimal form of this. So 0.042. All right, and compounded continuously. How much will she have in the account after 25 years? And so this here is our T. Okay. All right, so compounded continuously. So we know we are using this formula, PE to the RT. And let's go ahead and plug everything in. P is 6,500. E is a number. R is 0.042 times T, which is 25. Okay, so right now what I want you guys to do is punch that into your calculator. Make sure that you're able to do it correctly, and then hit the pause button and come back to see if your answer matches mine. Okay, so you should have gotten $18,574.73. Okay, so here's another part to the problem. How much is interest? Okay, so I invested $6,500 and let it sit there. And now I have $18,574.73. So how much of that was interest? Punch that into your calculator. So you should have gotten $12,074.73. My money made me $12,000. Okay, so that is basically it. All of the problems that are compounded continuously pretty much work this way. So the important thing is being able to keep your exponent in parentheses and making sure that you know how to enter your number E on your calculator. Okay. All right. Again, if you have any questions, make sure you text me, make sure you email me, or request a Zoom meeting. Okay. Enjoy your day.